Hey guys, welcome back to the channel. I have another Cummins Dodge Ram 3500 computer here. This time this is coming from Louisiana. The customer name is Zach. Zach, this is your computer. He sent me also a paperwork with his information, which I just kept the zip code and I guess the CD. So you guys can see that it's a 2004 Ram 3500 with a 5.9 Cummins diesel. Um, Problem, truck will not start and I'm receiving no communication and link error messages in my scanner. I am bolted and removing and the ECM from the blog of the truck and took it over to a local business named Matt Tunes, and they specialize in tuning and testing computers. They bench tested my ECM and told me that the test failed because there was no communication. They told me that my computer will need to be rebuilt or replaced. They do not perform a rebuild service and told me to go home and do my research. That is what led me to your business. Hopefully, you can help me. All right, so Zach, I don't have really good news. I have tried everything with this computer and I cannot make it work. This is your folder, and I see, as you can see, guys, I've been doing a lot in this computer. I have gathered a lot of information, and this is not really a common thing. This is the first time that I experience a computer that I cannot repair on these old ones, but I think the problem is actually in the microprocessor. Um, I cleaned his computer because this was really, really, really dirty, but still, I mean, it makes no difference, even though it's clean. I even changed the EEPROM. I'm been trying to do tests. I check the crystal oscillators and I can see the crystal doing, his thing, and I cannot still make it. This is just for my records and his. Um, like I showed in another video that I probably already uploaded before this one, I have gathered my own information, most of the common power rails, all the pinouts on the computer inside, sensors, sensor grounds, communication if it's uh, um, an old like this 2004, if it's a new one and it has a CAN bus, it will be on these pins 4 and 5, and you can see all that in here. I also did more, and it's on the other side of the board with markings. Again, this is again my information. Just follow up the main players in here due to the same. I'm trying to make the computer communicate and not. I cannot make it work. So luckily for me, I have a computer that actually works in here, and this is from Ira, and I'm gonna be able to show you what I can see here. So I did check all power rails, and actually the computer right now is on. So let me connect the multimeter. I got the multimeter out. Um, Main power rails, 13 volts here, 3.35 volts, 6 volts, and then 13 in here. So I know, well, this is going to be a little backwards compared to what we have in, to what I have there. Gotta be a little backwards, but yeah, so we have to have here 13 volts, and we got battery voltage. This one will be at 3.3 volts, 3.4, so it's fine. This will be 5 volts in here. And you got the 5 volts. These two should be 6 volts each. Sorry, guys. Let me make sure that you guys see that. 5 volts. Sorry, right here, 3.4. And then we got 6 volts here. 6 volts. In the other one, I'm trying to do this carefully because, as again, it's hot. And I don't want to damage the computer. This coil should have 13 volts in here. All of that side, the upper side is 13 volts. All these caps should be battery voltage, and they are all alive. And believe me, I did all this check and everything is good. This should be also on. Let me just see, because I don't see. Yeah, so we got battery voltage, and I want to check the other side too. And we got battery voltage. So as you can see, everything is powering up. Even if I check the 5-volt reference for the sensor, which I have in here, so pin 23 and 20 and 33. So you see, that will be third, and fourth, third. So third, got the final reference, and third, we got the final reference. So the computer is on, but that doesn't mean it's talking. That doesn't mean it's actually logic in it. And how do I know that? Okay, so this is where I need to go a little deeper into the test and show you what I have done. Right, with the computer on, and you'll see this on the other computer that I'm about to connect to. So what I have here is, again, as I have on the bottom description notes, what each channel is. So blue channel is DLC7, red channel is DLC12, and green channel is DLC2. The DLC2 with just ignition on should have something in it, communication, and it's not. So right now I got no trigger, so this is anything that is there, it should show. I even going to put a trigger here. So let me put a trigger in channel automatic and channel C. But as we see, there is nothing in there. So I can move the trigger, I can do whatever I want, and nothing is there. So the trigger is looking for something, but it's nothing, and the computer is on. Everything is connected. We just check the powers. So things that I also gather is, and this is what I know, the microprocessor is dead. And let me just show you. So I'm going to put this in here and put this in here. So this is the EEPROM. So right here and next to this IC, we have an EEPROM that is in charge to actually activate the communication. This has a port, so regarding the main things that this needs to have is the ground and the power, right? Fiber reference and the ground is also the SAK with CK and hold are very important because if that is in hold, if pin 7 is low, it will stop communication, but that will not stop pin 5, which is a serial data in, and pin 2 is serial data out. So we can see that if I come down, again, from here, SOS serial data output. PIN is used to transfer data from the the EEPROM out to a resequence of, of the computer, right? So, but then the SI is serial data input. Serial data input PIN is used to transfer data into the device. It receives instruction, addresses, and data is slashed on the rising edge of the serial clock. And so the serial data clock, obviously, SAK is very important. So these are, the pin is used to synchronize the communication between a master and a slave, or the EEPROM. Instruction addresses data presents, blah, 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 right? So we need to check these three pins. Obviously, I'm going to check powers and grounds first with you, and then we're going to go into a good working computer. So let me get the microscope so I can see and put this safely. So we need to go over to pin 5. Let's see pin 8 first. Pin 8 is right here. So this should be 5 volt reference. And we can see that is indeed 5 volts. We got a good ground in pin 1, sorry, in pin 4. So pin 4 is right here. And that is a good ground. So power and grounds are there. So let's see if we got serial input SI pin 5. This should be communication. We got a 5 volt reference. Nothing in there, so there is no communication. Let's see pin 2, serial output. Well, data output, right? So pin 2. I am moving everything in here. Pin 2 is 0. There's nothing going out. Why? Because there's nothing coming in. Let's see pin 6. Pin 6 is right here. All right, so pin 1, 2, 3, 4, 5, 6. The clock is down. There's no clock. So strike 3 out. This computer is dead, and that is microprocessor. So you have all the voltage rails this computer needs. It has a brand new EEPROM that I put in there. This has also a serial EEPROM in here that I can add. It's a flash memory, a flash EEPROM, and I don't have that. I don't have anything to copy it, and that will be actually just beyond the point of explaining to try to repair a computer that he probably can get for less expensive that it will cost to keep trying, because this will be just to keep trying. So I reach a point where I do the tests and I give my recommendations, my diagnostics, and I said it's not recommended to spend more money on this. This is just get another one. And I think this is what I'm going to tell to Zach. So I want to transfer these to a known good computer. Again, power on. We saw the voltage rails, nothing. And we got also another thing that I wanted to show you is here, the clock. So we got an oscillator here. Let me move my microscope so I can see. I'm gonna have to change the speed because I'm in 1 second per division. This might be a lot faster than that. Actually, let me open, because that's probably the best thing to do. Let me open the folder. And this is the nice thing about Picoscope. If you save, this is a save from the known good data. Like now I am only using channel D for the readings, and we're going to see that clock. So I can just run this now, and this is going to be, it has a frequency reading. Right now it's reading just air. All right, so I'm going to put it here, and we do have something is reading 462. That's nothing in there. And then, oh, let me see if make sure I'm in the right one. Yeah, I'm in the right pin. Let me actually read it in here, because this is actually down in from the clock speed, the clock. So this is what we want to see. So this is the same data coming from that oscillator, just after operation amplifier. So it amplifies the signal so that can be read and used for the clock. So that is there, and that is on that IC. So the next side of that same oscillator is right here, and we can see we got the 4 megahertz signal. So everything is there for that clock to start. The microprocessor has the crystal, has, I mean, the oscillator has the voltage rail, has a good EEPROM, and it's not working. That's it. For me, this is it. All right, let me transfer this to a good computer, and we can see that talking, and I'll show you how a known good should look. All right, so this is again, that's SAC, and this is another computer that I have here ready to go. This is a known good computer. This is working 100%. That things that I wanted to start with. So let me go back to the setup where we can see the actual communication. So let me again open a folder where everything is, you see DLC 7, 12, and 2 talking. All right, let me run this. Let me take this cursor off the screen so we don't need that. I'm going to make this big for this capture. So all I'm going to do is turn this on, and I want you to see the red channel. See the red channel? That's pin 2 in the DLC. You see, I got the trigger in channel A, and it's making no difference. I can make it there. All I will do with that is stab the capture right there. But so without a scanner talking or connected, all you will have is that on pin 2. Unless you connect the scanner, this is all you will see. Pin 7 and pin 12, which will be a 5 volt signal, will stay high unless you connect the scanner. So we see we got 5 volts in pin 12 and 5 volts in pin 7, but nothing is going on. So if I turn the scanner on, right, we're going to see this. I can, again, I'm going to show you this so you guys can see that this will not work in auto ID. So don't even waste your time, because it will not work. I'm just going to back up so a little bit so you can see the image in there. But in the meantime, this is trying to do an auto ID. It will not work. So we can skip this. All right. So we're going to end this one. You go over, if you're here, you just select the scan. This is on the tab down scanners. We're going to American, Dodge, and we'll select the vehicle. Let me see if it is read the bean after, because I was actually reading, okay, 16 bean connector, Dodge, and this should be a 2003 Ram truck. There's a whole bunch of warnings. If it's a Sprinter to use something else, I don't know what that is. So let's connect to the PCM. And again, until that is click, nothing will happen. But now we will start seeing communications. I'm going to make this capture a little far away so we can see how now the DLC7 and DLC12 are now active. And this is because the scanner is trying to communicate, and it does. And actually, it read the bean after you do this. So I don't know why it doesn't do the auto bean, but then when you manually select it, it's reading the bean because that's the bean of that computer, 100%. Now, in this position, again, no communication because we're not really using the scanner for anything. If you want to see activity in there, you want to go into read data stream and then just select anything. Um, Battery temperature, let me see, volts. This will be a 5-volt reference. Okay, so as long as that is there and the computer is talking to the scanner, you will see activity in pin 7 and in pin 12. On the other hand, the activity on channel on pin 2, sorry, yeah, and then pin 2 and the DLC has to be active all the time. It doesn't matter. As long as you key on, that needs to be on. All right, so that is a known good. So now let's do a few more tests. I want to use this and I want to change this a little bit because I'm going to use it for what we're doing in here. So I'm going to put channel D in 12 bits, and this is only with this oscilloscope. I'm not sure if the 4425A can do it or not, but this is 2 gigasamples oscilloscope, so this is very capable. I can lower it to 10 volts, and I have an attenuator 20 to 1 in there to make sure that I don't damage anything, and that's how I safely can read the clock and all the stuff. All right, so I'm going to go over to the same positions that we were before. So we're going to, let me just get into pin 3 here. I'm going to have to change the speed. The voltage and the speed are going to have to change a lot because this is a very small signal. So I'm putting them into 2 volts and I'm using that. So let me make sure that we can capture that data. I got to go faster. So let's go into 200 microseconds because this is, and I'm going to put a measurement into frequency and channel D. That will tell us when we are connected and we are reading anything. I should have just turned the other channels off because there's just going to be a blur, not a blur, too big for what we're really looking for in here. So 50 microseconds. I'm really trying to zoom in into this signal so we can see it. I have to go more than that. 5 microseconds. So this is a very fast signal, and we're starting to see the signal. So we can see how that is in 4 megahertz, and that is a good signal. Oops, just spoke myself. Yeah, you see, this is why I was using the other one. You see now this is becoming just not necessary to have the other one. So let's just open the other capture so it's ready to go. See, now this is all set up, and I'm in 500 nanoseconds per division, and I'm in 10 volts. But yeah, this is what I need to read that signal. So if we put this back again in there, and we saw those working properly, I just want to show you that these are indeed. You see, we got one of the clock, 4 megahertz. I'm going over into the other pins. I'm just going to keep you there. You can see that signal is a little bigger, and this was happening on the other computer as well. But let's go over to the EEPROM this time now. All right, so we're going to go over to the EEPROM. Voltage wise, we can stay there, and we're going to do the same thing. So we don't need to check powers and grounds. The computer is talking, right? So we're just going to go over to pin 5 SI, pin 2 SO, and then pin 6 SCK. All right, so let's go pin 2 first. That's SO. I should probably change the speed because now this is not as fast as the clock. So let me readjust that so we can see something that makes more sense. But we see activity. That's pin 2 on the EEPROM. Hopefully you guys can see that. So that is serial output. Obviously, if we got serial output, we got to have serial input. So we go over to pin 5, which is on this side, and we had the same. We got input. So we got communication. That microprocessor is talking. It's telling this EEPROM what to do. Let's go over to pin 6, SCK, sorry. And we have the clock. You see? So this is all coming for or from the microprocessor to control the computer itself to make it work without the commands from the microprocessor to go out. I don't care if you had the powers and grounds and everything, nothing else will work. And that is coming from here. So Zach, your computer is definitely not repairable. I'm sorry to give you the bad news, but that is all I can do. I hope that you guys see how much information I'm trying to share here. And if you're doing tests in computers, also if you want to understand what is a test in your computer, how long it takes to check a computer, because remember, this is not that you're sending a computer to a RAM dealer or I don't know, electronic repair facility. I work in all computers, so have all the information is impossible. I have to gather and gather information. It's hours and hours and hours of time to work in one computer. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye bye.